All right, today we're going to learn about quadratic functions, and I have the formula for quadratic functions right here. The thing that we need to learn about quadratic formula is the a value is always the number in front of the x squared. In my example down here, I have the a value as 1. The b value is the number in front of x, and ours is negative 10, and the c value is always the number that's by itself, 16. Now, the order in which you write this doesn't really matter. You just need to remember that the a value is the number in front of the x squared. Normally I wouldn't write this 1 here, I would keep it invisible, but for today's purposes I actually wrote the 1 here so that you can see the a value is 1. Now the thing about quadratic functions is, when you graph it, and I have a screenshot of a graph here, it makes a parabola. A parabola is this curved line that looks like a U, or if it's an upside down U, if it opens down. We have two x-intercepts, 2 and 8. The vertex is at the bottom of the graph, so that means this vertex is a minimum, and the vertex is 5, negative 9. And with parabolas, you can actually draw a line of symmetry, which is the invisible line that goes straight up and down. And if I draw this line, it would look like this. So the axis of symmetry is this vertical line, and it's x equals 5. And the reason we know it's 5 is because the x value of the vertex is 5. All right, with this lesson, we're going to start off with the warm-up, which is to help us remember function notation. Now, function notation is when this number right here, f of 1, that 1 is your x value. So I'm going to take this 1 and I'm going to plug it in for this x and this x, and I'm going to solve it. So f of 1, instead of x squared, I'm going to write 1 squared, plus, instead of 3 times x, it's 3 times 1, plus 4. 1 squared is 1, plus 3 times 1 is 3, plus 4. 1 plus 3 plus 4 is 8. So f of 1 equals 8. Now, number 2, f of negative 1. So again, instead of x squared, I'm going to write negative 1 squared. And remember to put your negative 1 in parentheses. If you type that into your calculator, if you don't put the parentheses, it'll give you the wrong answer. Plus 3 times negative 1 plus 4. Negative 1 squared is negative 1 times negative 1, which is actually a positive 1. Negative 3 times negative 1 is a negative 3. And then bring down my plus 4. 1 minus 3 is negative 2. Plus 4, and negative 2 plus 4 is a positive 2. So the function notation f of negative 1 equals 2. All right, now the next problem in this section is involving recognizing patterns. And I have figure 1, 2, 3, and 4 here, but it might actually be easier for you guys if I start at 4 and work my way backwards. To get the number of pennies in figure 4, if I counted them, it ends up being 16 pennies. But if I'm looking for a pattern, I would say there's 4 pennies on the base and 4 pennies on the height. Well, if I looked at the area and multiplied 4 times 4, I would get 16. Well, if I work backwards to figure 3, there's 3 pennies on the base and 3 pennies on the height. And again, 3 times 3 would be 9 pennies total. And that's true for figure 2 also. 2 times 2 would give me 4 pennies. And over here for figure 1, 1 times 1 is 1 penny. Now, if I wanted to figure out, I'm on question 2, how many pennies would she need for figure 5, 6, and 7? I could just continue this pattern and say 5 pennies times 5 pennies would give me 25 for figure 5. And for 6 would be 6 times 6. So figure 6 would have 36 pennies, and then figure 7 would be 7 times 7 at 49. Now, question number 3 down here. Which figure would Maddie create with exactly $4 in pennies? Now, $4 in pennies is 400 pennies. So we need to take some number times itself and equal 400 pennies. So I'm going to put x's here because I don't know what this number is. And since I put an x here, it has to be the exact same number. For instance, like 5 times 5 or 6 times 6. So x times itself equals 400. Now, an easier way to write x times x is to rewrite it as x squared equals 400. Now I'm going to go over here to the side and I'm going to solve that. So x squared equals 400. The opposite of squaring something would be to square root it. So the squared and square root cancel each other out. I bring my x straight down, I bring my equal sign straight down, and the square root of 400 is 20. So figure 20 would give me 400 pennies, or $4. Number 5, write an equation to determine the number of pennies for each figure number. Define your variables. Now, we kind of talked about it in the problem right before. I'm going to use y is the number of pennies, and it equals figure number squared. So that's why on the last problem we had, if we wanted 400 pennies, it was equal to x squared. So y equals x squared is our equation for this. Question 5, describe the function family which this equation belongs to, and we're talking about this equation right here. If I was to graph it on Desmos, it would not give me a linear equation, a straight line. It would not give me an exponential equation, which is a smooth curve either going up or going down. It in fact gives me a parabola, or what I like to call the U or the upside down U. So it gives me a parabola, which means this is a quadratic function. All right, this problem can be kind of difficult, so make sure you are really paying attention and follow along. A dog trainer is fencing in an enclosure represented by the shaded region in the diagram. The trainer will also have 2 square-shaped storage units on either side, and that's what's represented right here by these white boxes of the enclosure to store equipment and other materials. She can make the enclosure and storage units as wide as she wants, but she cannot exceed 100 feet in total length. All right, number 1 down here. Let S represent the side length in feet of one of the storage units. And again, this little box is my storage unit, and this little box is my storage unit. So when she says let S represent the side length, that means that this side right here is S, and over here, this side is also S. All right. 1A, label the length and width of the enclosures in terms of S. Now let's do the length. The length is the total distance from here all the way to right here. So if the total distance can be 100, I want to label this line right here, the shaded region, the top part. For instance, if this is 80 feet, that would only leave 10 feet for this shed and 10 feet for this shed because I have a total of 100. So I need to label the possibilities for this. Well, if the whole thing can be 100, that means I have to take away whatever this is and whatever this is from 100, and that leaves me with this distance right here. For instance, if this was 20, and that means this is 20, I would say 100 minus 20 is 80, minus 20 is 60. This one has to be 60 feet. So to write that algebraically, I would say we have the total distance of 100 minus the first shed minus the second shed. And rather than writing minus S and minus S, I can just simplify that and say minus 2S. Now, that is the distance going across. Now I need the distance of this side right here. And if this side is S, that means this side right here is also S. So if the length is 100 minus 2S, that means my width is just S. All right, 1B, write the function L of S to represent the length of the enclosure of the function of the side of S. Now again, to write an equation, I would normally write y equals 100 minus 2S, but since it says to write it using L of S, length, L of S, length, equals 100 minus 2S. All right, number 4, write the function A of S to represent the area of the enclosure as a function of side length S. Now I have kind of a crude drawing at the top of it up here. We are trying to get the area of the shaded region, which means we need to take side which is listed as s, times length, so s times 100 minus 2s. So I would simply write that as s times 100 minus 2s. And that's what's going to equal our area as a function of the side length. Now, some of you can write it like this, and you're going to notice I write it like this also. But if you wanted to, you could have done the distributive property and wrote a of s equals s times 100 is 100s, and s times negative 2s is negative 2s squared. So either one of these two equations is perfectly fine. All right, number 5, describe the area of the enclosure changes as the side length increases. So we have some examples over here, and the whole time I want you to think about which one of these would you want your dog running around in. For instance, number 1, the side length is very, very small. For instance, like 1 or 2 feet. And you wouldn't want your dog playing in here because it could just run back and forth, and that's about it. Probably couldn't even turn around. It could just walk forwards and walk backwards. Number 2, the side length increases just a little bit. But again, it doesn't look like you have that much of an area for your dog to play in. Number 3, again, they're increasing the side length and you're getting more room for your dog to play in. So it looks like the more you increase your side length, the more room you have for your dog. For instance, number 4, they've increased it some more, and look how much room your dog has to play in with that shaded area. Number 5, they've increased it yet again, even more, and we still have a lot of room for our dog to play in. The same is true for 6. They increased the side length and our dog's getting a lot of room. But at some point, if you increase it too much, you become just like figure 1. Your dog won't be able to turn around in there. So figure 7, they've increased it again, but it looks like our dog doesn't have very much room to run around in, just like figure 8 is showing right here. If you increase your side length too much, again, you are actually taking away from your dog. So somewhere in the middle is what we're looking for. Whether it's figure 4, 5, 6, or 7, we want to get the maximum room for our dog to play in. All right, B, use technology to graph the function a of s, then sketch the graph and label the axes. Now I went ahead and put a screenshot on here. Here's the equation that we wrote a while ago. Area as a function of side equals the side length times the length, which is 100 minus 2s. Now when I type it into Desmos, instead of s, I used x, and I get this parabola right here. And with this parabola, you can see we do have an x-intercept of 0, 0, and 50, 0. The y-intercept is also 0 down here. That's where it crosses the y-axis. Our vertex is at the top, which would make our vertex a maximum. And I know it doesn't ask this at all, but if I was going to draw a line of symmetry, it would go through the vertex straight up and down, and the equation would be x equals 25. And again, we know it's 25 because it crosses 25 right here, and we know that because of that number. So here's a graph of that equation as a parabola. All right, I skipped ahead a little bit to part B here. It says, use technology to determine the maximum area S. Describe what the X and Y coordinates of the maximum represent in this graph. And again, I'm going to slide over here to my screenshot. Here's my equation. It's the same equation as before. Again, x-intercept, x-intercept. Here's our vertex. What this means is the X value, again, X stands for S. So if the side length is 0, the area is 0 over here. If the side of our shed is 50 feet, then our area our dog has to play in is 0. So what I'm looking at is the vertex right here. It is the highest point, which means this is the maximum area for our dog. So the 25, which is our X value, or S value. So if we make the side of the shed 25 feet, it gives our dog the most room to run around. So the area is 1,250. So that's what these variables mean. X stands for the side of our shed. Y is the area of our for our dog to run around in. And we can see that over here. X, again, was where we put our S. So S stood for side length. And Y was the area. So that's why the variables match up. All right, now the next problem was wanting us to talk about the domain and range, and I'm going to start with the domain. Now remember, the domain is saying from what number to what number does this go to, the red line or the parabola. Now you can see right here it goes below the x-axis and also goes below the x-axis over here. But in reality, can I have negative side length of my shed? And the answer is no. So even though you can slightly see this red line underneath the x-axis, you have to ignore it because in reality you cannot have a side length that is negative. So the side length goes from 0 feet from 10 to 10 feet, 20, 30, 40 to 50 feet. It can be any distance between 0 and 50. So my domain for the side lengths of this is from 0 feet all the way to 50 feet. Those are all the possible side lengths. All right, now the range is the area. The range is going from 0 feet for the dog to play in all the way up to 1,250 feet for the dog to play in. It could be all of these areas in between all the way up and all the way down. It could be between 0 and 1,250. So I'm going to write my range as it could be all the areas between 0 and 1,250. All right, the next thing we need to talk about is when our parabola is increasing and decreasing, and this has caused kids a lot of trouble in the past, so I'm going to try to describe it to you in a different way. I want you to imagine this parabola was a roller coaster hill. This actually looks like a hill because it's an upside down U and it opens down. So imagine we always go left all the way to the right, just like you read a book. So I'm going to ask you, when is the parabola increasing? So again, if you're on a roller coaster, when are you going up the hill? And you would say right here, because it starts at 0, it goes all the way from 0 to 25 feet, it is increasing. That's when our roller coaster is going up. So I would write all the way from 0 to 25 feet. Now, when is our roller coaster decreasing? Well, once it's at the top, at 25 feet, it's decreasing all the way down to 50 feet. So from 25 all the way down to 50, it is decreasing. All right, suppose that there is a monthly meeting at the CIA headquarters for all employees. How many handshakes will it take for every employee at the meeting to shake hands of every other employee at the meeting just once? I'm willing to bet that there's going to be a lot less handshakes now with all this coronavirus going on, but number 1, use the figure shown to represent the number of handshakes that will occur between 2 employees, 3 employees, and 4 employees. Now, if we have 2 employees, that's represented by the dots. So here's employee 1, here's employee 2. There's 1 line, which means 1 handshake. If we have 3 employees represented by the 3 dots, there's 1 handshake, 2 handshakes, and 3 handshakes. 4 employees, again, represented by the 4 dots, 1 handshake, 2 handshakes, 3 handshakes, 4 handshakes, 5 handshakes, and 6 handshakes. 2 says to draw a figure to represent the number of handshakes that occur between 5, 6, and 7 employees. And I went ahead and put that data down here at the bottom to try to save a little bit of time on this video because it's already getting really long. Now, to get the equation that's over here, it's pretty difficult, so I went ahead and gave it to you guys at the bottom. But it's basically you take N represents the number of employees, so N times whatever the number of employees minus 1. So for instance, if there were 8 employees, it would be 8 times one number smaller than 8 is 7 divided by 2. If there were 10 employees, it would be 10 times one number smaller than 10, 9 divided by 2. So that's where I got the N times N minus 1 over 2. Number 5 says use technology to graph the function you wrote in question 4, and I believe I already have a screenshot of it over here. Now again, instead of N, I'm using X, so N or X times X minus 1 divided by 2, and it's going to give me this parabola right here in blue. And if you guys can see, I have a minimum. The vertex is right here at 0, 0. The axis of symmetry would be the imaginary line straight up and down, so it'd be X equals 0. The y-intercept, it also crosses at 0. Now this parabola does go from left to right, so it starts off right here decreasing. So if I was going to do increasing and decreasing, and we're actually going to do that real quickly, increasing, it's going up. Again, if our roller coaster was going up, it starts right here at 0 and it goes up all the way to positive infinity. It keeps going on forever and ever. And if I was going to do the decreasing part of it, the decreasing, I would say it's decreasing over here at negative infinity because it keeps going left forever and ever, and it's going down all the way to 0. So from negative infinity to 0, it's actually decreasing. All right, number 6, how is this orientation of this parabola different from the parabola for the area of the dog enclosure? How is it different reflected in the corresponding questions? Now, if I look over here, if you remember our dog enclosure, it opened down, which means it made like a giant upside down U. This parabola makes a U, so this one opens up. The reason being is right here, 0, 0, means if there were 0 people, there would be 0 handshakes. And as there's more and more people, you can see the handshakes grow exponentially right here. Now, we do have this side over here, but we can't really use it in this real life situation because you can't have negative 20 people in a meeting and have a certain number of handshakes because negative 20 people does not exist. So even though it gives us a parabola, we would really only start to look at it from here going to the right. All right, moving on. You can model the motion of a pumpkin released from a catapult using a vertical motion model. A vertical motion model is a quadratic equation that models the height of an object at a given time. The equation is the equation is of the form shown. Now this equation actually works for anything that you would shoot up into the air. Y equals negative 16 represents the gravity pulling our object back down. T stands for time. V stands for velocity, which is how hard you shoot it up in the air or how hard you throw it or hit it up into the air. And again, T stands for time. H stands for the starting height. Now, if you're thinking about a golf ball, you hit a golf ball off the ground, so the starting height would be 0. But if you are throwing a football, you don't throw a football off the ground. You throw it from about shoulder height. So shoulder height might be 4 or 5 feet up in the air, so the starting height might be there. If you're talking about a pumpkin being shot from a catapult, the starting height would be even higher than that because the catapult releases it pretty high up in the air before it actually is released from the catapult. All right, I'm skipping down to number 2. Write a function for the height of the pumpkin in terms of t. Now, right above it, it says, suppose that the catapult hurls the pumpkin from a height of 68 feet. So the height is 68 feet. And the vertical velocity is 128 feet per second. So those two numbers are the only two numbers I need to plug in. So where it says y equals negative 16t squared, and again, t stands for time, plus the velocity, and our velocity was 128 feet, so 128 times time, and then again, plus the starting height, our starting height is 68 feet. So we just wrote our equation for our pumpkin. All right, number 3, does this function you wrote have a minimum or maximum? Now, this is without even graphing it. Can we tell if it has a minimum or a maximum? And you can. This is one of those things that we were in the classroom when I was doing this problem. I would go over a lot of examples and I would say, do you recognize any patterns? But I'm trying to keep this short enough. It's already over 20 minutes. But the a value, and again, the a value is the number in front of the variable squared. In this case, is t squared. The 128 is your b because it's in front of the variable. 68 is your c. So the a value, negative 16. If it's positive a value, it's going to open up like this. But if it's a negative a value, it's going to open up down like this. So if it opens up, and I'm going to do that over here, it has a vertex at the bottom, which is a minimum. But if it opens down, its vertex is at the top, which is a maximum. So since this has a negative a value, I know that it's going to open down, so therefore I know it has a vertex at the top, so it's going to have a maximum point. All right, number 4 says use technology to graph, and I believe I have a screenshot over here. Here's what happens. Again, right here is the beginning part. This is where our catapult releases it. Now again, I know you have this part of the green line right here, but that's in the negatives, and we can't have negative time for a pumpkin. Like once it's released, time starts. We can't have negative 0.5 seconds, which is that right here. So here's where our pumpkin starts. It goes up in the air and it hits the maximum point right here. So it means at 4 seconds, it reaches a maximum height of 324 feet. And once it reaches its maximum height, it comes all the way down to the ground right here, at 8.50. So it takes 8.5 seconds for it to hit 0 feet. Now this graph does have two x-intercepts, negative 0.50, which means at negative a half a second, it's also at 0 feet, but can the pumpkin be at negative a half second? So no. So we have an x-intercept and a y-intercept and a maximum. And again, if we were going to draw a axis of symmetry, it would be the imaginary line going right here. And that equation would be x equals 4 because that number is 4. All right, number 7, use a horizontal line to determine when the pumpkin reaches each height after being catapulted. Label the points on the graph. And I have a screenshot of the graph over here that we're going to use to find A, B, and C, 128 feet, 260 feet, and 55 feet. So if we look over here, I use Desmos again, and I have my initial equation up here, and then I made an equation for each one of them, A, B, and C. Y equals 128, which gives me the purple line going across. Y equals 260, which gives me the black line going across, and y equals 55, which gives me the red line going across. So it's going to hit all three of these heights on the way up and on the way down, except the red one. So if we start right here, that's where the catapult is released. It's going to hit the purple line, which is 128 feet on the way up. On the way up again, it hits 260 feet. Then it has our maximum height. Then it's going to hit 260 feet on the way down, 128 feet on the way down, and 55 feet on the way down. Now notice it does not hit 55 feet on the way up. That's because it's at negative time. Remember, it was released at 68 feet, so how could it hit 55 feet on the way up? It can't. So it hits the purple line twice, once on the way up, once on the way down, once at 0.5 seconds and once at 7.5 seconds. It hits the black line once on the way up at 2 seconds and once on the way down at 6 seconds. It hits the red line once though. It does not hit on the way up, but it does hit on the way down at 8.1 seconds. All right, for you guys that are thinking about opening your business someday, this problem might actually help you. The Jacobson brothers own and operate their own ghost tour business. They take tour groups around town on a bus to visit the most notorious haunted spots throughout the city. They charge $50 per tour. Jesus, that's a lot. Each summer, they book 100 tours at that price. The brothers are considering a decrease in the price per tour because they think it will help them book more tours. They estimate that they will gain 10 tours for every $1 decrease in the price per tour. According to this scenario, how much money do the Jacobson brothers currently generate each summer with their ghost tour? Well, that should be pretty easy. If they're charging $50 per person and they give 100 tours, 50 times 100, they're making $5,000. So we're going to see if we can make these guys a lot more money than $5,000. Revenue is the amount of money regularly coming into a business. In this ghost tours business, the revenue is the number of tours multiplied by the price per tour. Your response in question number 1 can be referred to as revenue. Because the Jacobson brothers are considering a different number of tours and price per tour, the revenue can be modeled as a function. Number 2, write a function R of X, revenue of X, to represent the revenue of the ghost tour business. Let X represent the decrease in price per tour. So if they knock $1 off, the decrease is 1. If they knock $10 off, the decrease is 10. Write an expression to represent the number of tours booked if the decrease in price is X dollars. All right, so for every dollar they knock off, they're going to get 10 more people. So it's 10 times however many dollars they knock off. If we knock off $1, we'll get 10. If we knock off $2, we'll get 2 times 10, which is 20. If we knock off $5, we get 5 times 10, which is 50, plus the original 100 tours that they already got from earlier. Write an expression to represent the price per tour if the brothers decrease the price X dollars per tour. So they're starting off paying $50, and we're going to knock off money, so I'm going to subtract, but we don't know how much we're knocking off yet, so I'm going to put X. So 50 minus X. Use your expressions from Part A and Part B to represent the revenue R of X as the number of tours times the price per tour. So again, the number of tours was 10 more people per dollar we knocked off, plus the 100 people we already got. And the price per tour was going to be $50, but we're knocking some off, so we're going to say 50 minus x. Number 3, use technology to graph the function. I think I've already got a screenshot over here. Yep. So again, I have the number of tours times the price per ticket. And the graph is going to give us a parabola right here. Now, if we look at this parabola, if they charge, if they make no change, if they knock no dollars off, remember X is the number of dollars they are knocking off. So if they knock no dollars off, they're going to make $5,000. And if I look up here at my vertex, it says if they knock $20 off. Now, if they knock $20 off, that means they're charging $30 per ticket. So if they knock $20 off, they're actually going to make $9,000 instead of the $5,000 they were making earlier. So it's in their best interest to knock $20 off their ticket. I know that doesn't seem smart, but if you knock the price off, you're going to get more business, and they're going to end up making a lot more money. In this case, they're going to make $9,000, which is $4,000 more. All right, now this is going to be your homework for tonight, and I'm going to put a screenshot on Schoology for you, but I wanted to make sure that you guys got started off okay with this. The citizens of Harrington County have an existing dog park for dogs to play, but have decided to build another one so that the park will be for small dogs and the other will be for large dogs. The plan is to build a rectangular fenced-in area that will be adjacent to the existing dog park as shown in the sketch. The county has enough money in the budget for 1,000 feet of fencing. Number 8, determine the length of the dog park in terms of the width, W. Now, I wanted to point out to you guys that they already have fencing right here because that's the existing dog park. So the 1,000 feet has to be for this wall, and this wall. Now, if they have 1,000 feet for all three, that means if I take away 1,000 minus this, it's going to leave me with the amount of fencing I have for here. So I would say to get the length, it would be 1,000 minus one side minus the other side. But again, instead of writing minus W, I would simply write minus 2W. I don't know what happened with that W. But 1,000 minus 2W is the length of the park. All right, part B, write a function A of W to represent the area of the new dog park as a function of the width. Now again, the length right here is 1,000 minus 2W. So to get the area, I'm going to take W, which is that side, times this side. So I need to write an equation that says W times 1,000 minus 2W. And that's good enough to get you guys started on this problem. I just didn't want you to get confused and not know where to start, but you should be able to do the rest of it from here. Good luck.